A heat engine utilizes a heat source at 550 degrees Celsius and has an ideal Carnot efficiency of 30%. To increase the ideal efficiency to 40%, what must the temperature of the heat source be? All right, so this one's actually quite a bit simpler than some of the other thermo stuff. All these efficiency problems really don't have a whole lot to them, so let me set it up for you. So this is the efficiency formula from your formula sheet. Pretty simple. The hot temperature minus the cold over the hot. Or you could do a little bit of tricky algebra and divide both sides by the TH over here. So this chunk turns into 1 and this chunk turns into minus TC over TH. Both formulas say the same thing. It doesn't matter which one you use. And they told you that the efficiency was 30%. So we've got to find out what the cold temperature was in the original situation. All right, so we tossed the numbers in, and they said it was 30% efficiency, so I just toss a 0.3 equals 1 minus whatever the cold temperature was in the first situation at 30% efficiency over the hot temperature, and you just do a little bit of algebra here, and you get the cold temperature was 385 Celsius. But the question was asking, if we want it to be more efficient, we'd better make there be a bigger difference in the temperature. So to make an efficiency of 40%, we'd better have a bigger split in this temperature. And the cold temperature stays the same, but they said we can change the temperature of the heat source to make it hotter so that the efficiency goes up to 0.4. And we can use this cold temperature that we just figured out to see what the hot temperature needs to be to make it more efficient. All right, so moving right along, I take the cold temperature and I toss it back into this formula, only now we're setting it for a 40% efficiency. So we put the number in there and we're looking for what the hot temperature needs to be in order to make this true. And then it's just a matter of a little bit of algebra again. I subtract the 1 and all that good stuff. And we're solving for TH. At this point, rather than spending any more mental gymnastics on it, I like just making both sides a fraction so you can just cross multiply it. Okay, so working this out, you get, you cross multiply these two, you get 0.6 TH equals 385. So the new hot temperature to give it a higher efficiency is 641, which is quite a bit hotter than the original one that we had. So to raise it from 30% to 40%, we had to make this thing quite a bit hotter. In real life, though, just making it hotter alone won't make it more efficient, because if it's hotter, more heat's going to leak out of the thing in the process as well. So it's kind of an ideal mix between the two. But in theory, we're assuming that no energy is lost in terms of heat leaking out to the environment, and that's why we call it a Carnot engine. That's what they mean by that. All right, good luck on the homework quiz.